All right, I'm going to be going through a walkthrough today on how to do a basic cabinet or bookshelf in Fusion 360, specifically using it for plywood for CNC. So today I'm going to be starting off going into the solid workspace, going to the modify panel and down to change parameters. I'm mostly going to be focusing on the user parameters and their specific value in parameterizable CAM, and just kind of looking into the extent of how this can benefit what we're doing. So we're going to start with plywood as our first variable. We're going to be using 1/2 inch ply for this, and so we'll just enter 0.5. The nominal real value of plywood is more like 0.48, and it totally depends on your manufacturer and where you're getting your ply. Since I'm mostly doing dados, I like to use 0.5 and just give myself about 1/100th inch on each side. It's just easier for the kind of glue up that I end up doing with this material, and that's what I prefer. If you'll find with different materials that you like different settings, and you can always just go into your actual manufacturer setting and set offsets there. So yep, I start with this. It's nice to have also your material value be parameterized in case you're working in an especially humid environment and you want to compensate for difference in experience or expansion in materials, as well as using different materials. So we'll start there. It's a good starting point. We're going to set a cabinet length here, 6 feet. Nice thing about Fusion in parameters is that there's interoperability between units. So if I go 200 centimeters, it'll translate it automatically over to inches if that's your default. So we go 6 feet, enter there. Cabinet height, we'll do 18 inches for our height. Cabinet depth, do 18 inches here. I'm going to do a dado depth and define that as a parameter too. I like to do 150 thou for 1/2 inch ply. I think it's totally fine. The main reason I have a dado here is because he's pre-finished a lot, so it doesn't really need to be that substantial. You're not really getting any value from the strength of that dado. It's more just removing the pre-finished surface because it has no structural value, especially with PVA. So, and lastly, we're going to do divider count. And the cool thing is that we can have just an integer with no units defined. And so this is just going to be a standard integer value that defines how many dividers there are. So we're going to set that for 5, and then we're good. We'll hit OK. We're going to create sketch on the front plane here. We'll start from this origin point. We're going to set this to plywood and then cabinet length as our variables. So we have one long stretcher here that runs the base here. All right, next up, we're going to go here and have a piece that is cabinet height tall. And we're going to do minus plywood times 2. An awesome feature of Fusion is that you can do really simple math in the inputs using parameter values. So we can do plywood times 2 right directly in here. It'll subtract it from cabinet height, and we end up with 17 inches. So I actually set this wrong. I didn't set my width, so I gotta do this one more time. Cabinet height minus plywood times 2, and then our width will be plywood. Perfect. All right, and then at the top point there, we'll do plywood height and cabinet length here. Awesome. All right, so that's all we need for this sketch to start. Then we're gonna go hit E to open up extrude, and we're going to extrude the top and the bottom pieces to cabinet depth and set as a new body. Anytime you open a new component and you make the first extrusion, it always hides the sketch. So go to sketches, unhide that sketch. And then we're going to go hit extrude one more time, and we're going to extrude this left vertical piece over here to cabinet depth. And whenever you extrude with two faces that are touching each other, it will default the operation to join. So we don't want this. We want to set that to new body. Otherwise, we'll just be left with one big blob of all the stuff that we have. So we don't want that. All right, next up, before we do anything else, we're gonna repeat this bar, this piece over here on a rectangular pattern to stretch all the way across to the edge. But before we do that, we are going to extrude our dados out of this. So we're gonna select these two pieces here and hit V to hide them. We're gonna hit E and extrude. Dado depth here, join operation, since we want this to be a part of that piece. And same thing here. We extrude this top part out to dado depth and hit join. All right, fantastic. Now we can go back here. We can bring these back and cool. We'll hide this sketch just so we can see what's going on. Now what I'm gonna do is hit the rectangular pattern. I'm gonna set the type to bodies and select this piece here. Select my direction, so I know plane that it wants to run across. And then I'm going to enter cabinet length minus plywood, since it's running from this space here, and it includes this piece. So now this is letting me do a pattern from here all the way to this edge where this piece stops. And I can set the quantity of that piece to repeat on this pattern. So 6, 7, 8, however many you want. Now, instead of doing that, we can just enter the integer divider count that we defined earlier. So rather than just having that hard-coded, we can have a parameter that actually controls the repeat. The thing is that we set the divider count, so in order to have it reflect properly, we need to have divider count plus 2 just in the quantity value so that it excludes the beginning and ending pieces. Yeah, so now we hit OK, and we are left with all the pieces that we just repeated and our top and bottom stretchers. Now we're going to hit combine. We're going to grab the top panel and then set the top panel as our target body, set our tool bodies to all of these pieces here. And we're going to hit Operation Cut and make sure that you select Keep Tools. And I'm going to hide these really quick and just show you what that did. That basically cut all of our dados for those pieces out. And we have to do that one more time though for the bottom. So we go combine, select our target body down there, select our tool bodies up here, make sure Keep Tools is on, otherwise we'll lose all these vertical pieces, and hit OK. Awesome. So what this looks like now is we have our top and our bottom dados all set. Now, here's the really cool part about this situation. We can then open up our parameters dialog here and go ahead and scooch this over a little bit. All right, so we did everything correctly and have all our parameters here. To start off, we can override our plywood setting, and we want to change that to maybe 3/4. It will perfectly change all of our dados on all the pieces and all the thicknesses to reflect that properly. So it should work as long as our plywood is greater than our dado depth. Any material, like you could do 1 inch, 1/2 inch. All right, cool. We can change our cabinet length. Whoops, that's not correct. 46 feet is long, 4 feet. There we go. So we can override any of these, change them to anything we want, and it will retain the full functionality of what we're doing. So we can set our height to 12 inches. We can set our depth to 12 inches. We can change any of these however much we want, and it'll work. All right, and then we can change our dado depth as well. So we scooch in here. I change this to, say we want 1/4 inch. That'll change all the dados to 1/4 inch. And most importantly, it'll retain the cuts. So the actual action of the cut gets changed when you change these parameters in the waterfall. This is super valuable. So say that you wanted to, not have to go back and make sure that everything had that same depth. You can just change the parameter and the waterfall will include it across. And lastly, what's really cool is we can change the number of dividers here. So right now it's set to 5. We could change that to 4, change that to 3, we just wanted 2 of them, we can do that. The only limitation is that I don't believe we can go past the initial integer that you defined without probably running into some issues, because in these combine actions, these pieces haven't been cut yet. So since these new pieces didn't exist at the time that these combine actions were created, these did not get cut out of this material. So you can solve for that by just setting a really high divider count number when you first create it, and then if you set it to 10, you basically have full access to anything under 10 as your integer value there. I'm going to change these parameters so this is a little smaller so that we can fit this whole thing onto one sheet of ply. And then I'm going to show you how to lay out all of this onto a single sheet of plywood using the manufacturer setting. All right, now we're going to hop out of the design workspace and enter the manufacturer workspace. First thing we're going to do once we're here is go to setup and go down to create manufacturing model. Now, I believe that this might have been a beta feature at one point, and you might have to go into your preferences and enable this under preview features. I'm not sure if this is integrated fully yet, so just word to the wise there. We're going to hit create manufacturing model and then right click on that we just created and go edit manufacturing model. This is going to create a clone of our design workspace that is separated from the origin of that design workspace. This basically means that we can manipulate and lay flat our model without breaking our actual design reference. If we want to go back and make changes to that or do anything to it, we still have that. So now that we're here, first thing we're going to do is swipe select all of our bodies. And then we're going to click on new component up here and hit OK. What that's going to do is it's going to create components out of each individual body and make them their own separate component. Next up, we're going to go create, go box, and we're going to select the flat ground plane here, and then just wherever, we're going to make a 48 by 96 inch box. That is a 1/2 inch thick. This design workspace, the manufacturing model workspace, it breaks references to the initial space, so we don't have our user parameters, so we just have to manually enter our preferences. So 1/2 inch here, hit OK, we're all good. All right, next up, we're going to click arrange, and we're going to select all of our components that we just created over here, swipe select, and then we're going to go down in the dialog to plane, sketch, face, and hit select. We're just going to select this piece of plywood that we created. So now we have basically all of our individual pieces laid up on this body here. Height offset, we're going to do -0.5 since our pieces were sitting proud by 1/2 inch. So we'll just do that so that they sit flush with the material. And actually for now, I'm going to not do that just so you have easier viewing here. So there's 2 important parameters to notice down here in spacing. One is frame width. This is the actual distance from the edge of the plywood to the material. Ideally, you want this to be more than 1 inch. If you are using a vacuum pump system and know what you're doing, then you can set this however you want. If you're doing screws in the outside of your material or plastic raptor nails or anything of that sort, then I would recommend over 1 inch. It's never fun to break a bit on a screw. Typically, it's not really worth it. So, I mean, 1.5 inches is a luxury if you can afford it. This goes more into like material and work holding, and that's a whole conversation. But for the most part, I feel like 1.5, 1.25 is a comfortable distance to set screws. And yeah. All right, next up, object spacing. So this is the actual space in between each individual body that's getting laid up here. If you are comfortable with it, you can set your tool diameter to be the actual object spacing. I love doing this. I do this for pretty much all of my cuts. I use 3/8 inch compression bits for the most times. And yeah, so I just do that. I use 3/8 inch spacing and then set all my tabbing so that pieces are interconnected. It leads to very little wasted material and very easy cleanup because you don't have to deal with odd offcut sizing. You can pretty much just have really, really high efficiency usage. If you don't want to do that and you want to have pieces not interconnected for whatever reason, you could set an object spacing of 2 inches or something. This is all kind of interpretable and depends on how you feel and how you use your machines. All right, so we're gonna just hit OK there, and now we have all of our pieces laid up. I'm gonna actually go back though, because I forgot to change back my height offset. So -0.5, so that everything's flush. Awesome. So we can hit Finish Edit, and we are left with all of our pieces laid up perfectly with the right spacing and offset that we want for our material. Next up, what we would do is go create a new setup. This is going to depend a lot on your machine. I am going to set this up for Mach 3. So I'm going to just select this point here. We'll do model box point and set our model as this piece of ply that we defined earlier. And we'll set our box point as our top. Okay, so when I set this up, I like to use a model and do model box point. Then I do a fixed size box. I do 96 by 48 by 0.5, and I do offset from top. All right, now that we have our actual setup defined based off of this model, I will hide this model. And within this setup, go and select our 2D pockets. And our only pockets here are going to be these dados. So I'm just going to go through and select each of these. Awesome, so now we have all of our dados selected here. Okay, cool, fantastic. So this is all of our pockets done, and then we'll just do a 2D contour for each of these bodies here. Make sure you get the bottom of these so that it gets the right measurement and not these tops. Cool. We have all of these bodies selected by their contours on the bottom edge. And next what we'd do is we'd set tabs for each of these. So this is definitely like personal preference. It just depends a lot on how you like to set up your material, your work holding, and you may, have a system for your things. So when I do this, I do 0.5 as my tab width and an 1/8 inch, sorry, yep, 1/8 inch for my tab height. And then I go not by distance, but at points, because I am making adjacent tabs between two pieces. So I need to make sure that they are on both pieces of material so that they interconnect. And I want to just make sure that I'm making tabs right next to each other so that these pieces are connecting. So that way it cuts out all the material between them and preserves their connection. And it looks like we're good. There we have plenty of tabs. We have each piece connected, interconnected. I'm not going to bother with the rest of this stuff right now, and we're just going to hit OK. All right, fantastic. So I'm going to preview these and just show you what this will look like when it goes to be done on the machine. So we'll go simulate and hit play. All right, so our final thing, we will have our dados cut. Here you can see those channels for our dados, as well as all of our tabs cut out here. Yep, and there you go. Now you can take this and post-process the setup however you want and export to whatever machine you're running. That's the gist of how to go from parameterized design for plywood cam directly over into manufacturing as smoothly as I know how. Right on.